Hey guys, welcome back. In this video, I'm going to prove the quotient rule. I hope everybody had an opportunity to look at my playlist for some of the other proofs, including the power rule and the product rule. So let's prove the quotient rule. All right, so we have h of x is equal to a function divided by a function. In other words, there's going to be x in the numerator and x in the denominator, and that's great. So first step is to make sure that we have h of x plus h. So that's going to be this right here, okay? So what is the definition of a derivative? The definition of the derivative is the limit as h approaches 0 of h of x plus h minus h of x over h. Well, guess what? We did most of this already. We have f of x plus h, that's, or h of x plus h, that's that guy. And then we have h of x, that's that guy. So I just put those right there, which brings us to this part here, okay? So h of x plus h minus h of x over h. Now I'm going to combine fractions to make it into one term. And I did my little crisscross tomato sauce and I got my fractions. So I found my common denominator and then I brought this h up there. So pause the video, make sure you guys know how to find a common denominator. If you are watching all my videos, then you know my little crisscross tomato sauce. So I have f of x plus h times g of x minus f of x times g of x plus h all over h times g of x plus h times g of x. So this is what I have right now, and I have this guy here, limit as h approaches 0. Now what I did here was I removed the limit as h approaches 0 only because I don't have room on this page. So I'll put it back later. All right, here's the key to the proof. You have to add this green guy here and take away the green guy here, okay? Once we add and take it away, we know that we have not changed the problem. So we didn't change this problem because we added a number and took away a number, or we added a function, took away a function. So it's exactly the same. Now, what this allows us to do, if you guys notice, I'm going to use a black pen. I'm going to say g of x and g of x is in both of these. I'm going to factor it out, which I did right there, okay? Once you factor it out, you're left with f of x plus h minus f of x. Okay, that's for this guy right here. Pause the video if you need help. Then I'm going to do the same thing. I'm just going to now factor out the f of x, okay? Once you factor out the f of x, you're left with g of x plus h and g of x. But what I did here was I didn't just factor out f of x, I factored out a negative f of x because I'm trying to get this into the format of g of x plus h minus g of x. Now, I have my denominator here. Let's choose a different color. I have my denominator here, and I'm just going to put that denominator under each piece, okay? So I'm now going to apply the limit as h approaches 0 for this entire expression, all of it. So what happens here? Well, f of x plus h, let me get my highlighter, I'll get a different color. F of x plus h minus f of x over h, well, that's called f prime. Do you guys remember that? So that's that guy. The limit as h approaches 0 would then make this h go to 0. So that gives you x plus 0, so that's g of x, and that gives you g of x, okay? Great. Now, here, I have the same exact thing, g of x plus h minus g of x over h, that's g prime of x, okay, when we apply the limit as h approaches 0. And then once again, we have h approaches 0, that gives you g of x and g of x. So putting this all together, you get the quotient rule, which is g of x times f prime of x minus, okay, let's highlight this. So this is your quotient rule. It's g of x times f prime of x minus f of x times g prime of x all over g of x squared. The quotient rule, in short, says keep the bottom function, where is it? Keep the bottom function, derivative of the top function, minus keep the top function, derivative of the bottom function, all over the bottom squared. So this is our proof. And now in our next video, we are going to be doing example after example after example. So please come back and watch some of the examples on how we apply this derivative.